Chapter 4, Fluid Conductors and Connectors. Objectives of this lesson are to explain the influence of fluid velocity on conductor selection. You guys ever turn on the garden hose and stick your thumb over the end of it?
Yeah.
Mm-hmm.
Velocity increases quite a bit, doesn't it?
Mm-hmm.
Describe how piping is used and installed in hydraulic systems. Describe how tubing is used and installed in hydraulic systems. You know what the difference is between tube and a pipe?
I was gonna ask what the difference between a tube and a hose was, but
One's hard, one's soft.
Matthew?
With piping, because they're made of hardened metal, you can't just bend it. It's not as flexible as tubing is.
There you go. Tubing is thin enough in the construction of its walls that it can be bent and formed. Pipe, not so much. I mean, you put enough force on a pipe, you can bend it.
it ain't going back.
It's not typically designed to do that. Describe how hoses are used and installed in hydraulic systems. Describe connector thread identification practices and thread types. There are far too many. Like you have NPT, BSPP, JIC. There's a whole mess of them. Describe the different cleaning methods used for installing a conductor. List pressurized hydraulic equipment safety standards. A velocity conductor. Conductor is a device used to transmit hydraulic fluid between various components in a hydraulic system. How do we get it from point A to point B? So a conductor is either a hose, a tube, or a pipe. Or I guess you could count manifold and a bunch of other things in there. Now, conductors installed in hydraulic systems are designed to be compatible with the type of hydraulic fluid to be used and be able to withstand the velocity required for the application. So if you put on a flimsy little hose and you run it up to 10,000 PSI and you're cruising through there, 50 gallon a minute, it's probably not going to survive. Wasn't it cute? Bet you guys didn't know that's what hydraulic fluid particles look like. Now you do.
Just in case.
They're blue and they're oval. Okay, so in order to find velocity, it is just distance over time. Same velocity formula that we use for cars and roller coasters and buses and asteroids and meteors and whatnot. Typically, in a hydraulic system, we're not going miles, so we knock it down into a more manageable unit of measure like feet per second. Unless you're anywhere but the US and it's meters per second. Velocity and flow through hydraulic pipe. We have a flow rate of 5 GPM in a pipe that is that diameter, and then you squeeze it down to that diameter. Then in order to get the same 5 GPM through there, you have to accelerate. It must go faster. There's no choice. You try to cram the same number of blue particles, blue oval particles, through a smaller opening at the same rate. Determining conductor size. Flow velocity in a conductor is related to the area of its inside diameter, or ID, Inside area of a conductor can be found by calculating the inside area or by using a nomographic chart. Anybody have any idea what a nomographic chart is? Matthew?
It's a chart used where you chart a line and to calculate the, inside area of the conductor.
Okay. What is plotted on the chart? And if you have a chart, you have to be comparing at least two different things, right?
You'd be
One in X axis, one
comparing,
in Y axis.
you would be comparing two known variables,
Okay, which two?
the length and the height and
Good guess, incorrect. You're worried about size of or area of a conductor. You're only worried about how fast is fluid moving through it and how big around is it.
Well, out of curiosity, I looked at a study of using graphs, or I wouldn't use the word in the definition, but study using graphs or grams to represent mathematical laws. Kind of a vague definition.
Yeah, it's basically just like any other XY diagram you've ever seen in your entire life. You're plotting distance over time, pressure over area, you know, whatever. For lower velocity, a conductor with larger area should be used, and vice versa. So lower velocity, larger area, higher velocity, smaller area. Remember that. Flow velocity requirements can be different for each system depending upon the type of line and hydraulic fluid used. If you're dealing with a fluid that is more viscous than another, obviously your flow requirements will be different. And therefore pipe sizes and whatnot will be different. Now, hydraulic components, devices, and power supplies must be connected to each other so that power can be transmitted through the conductors and the connectors in the system. Does that remind anybody of their electricity class? It is still considered a circuit. You have power supply, which is your pump. You have the conductors, which are the hoses and the pipes and the tubes. You have your load, which is, you know, air cylinders, hydraulic motors, oscillators, you know, and a whole mess of different things you can use for a hydraulic system as load. And then, of course, the fluid eventually has to get back to the tank so it can be reused again. Conductors include piping, tubing, hoses with their related connectors. Piping is a passage or a series of passages that include power systems that are constructed of metal, plastic, or plasticized rubber and conforms to ANSI standards. Anybody remember what ANSI is? Matthew?
American National Institute Industry something, safety industry.
First two words were right.
Standards Institute.
There you go, American National Standards Institute. Piping is the most common way of transmitting fluid in both hydraulic and pneumatic systems. I don't know that I necessarily agree with that because typically in a pneumatic system, it's more tubing than it is piping. Whether it be plastic or metallic tubing, it's still typically tubing in pneumatics. Unless you're talking about plant air, you know, like everything coming off the compressor, and the compressor room is piped. But then once you get to the air drops, it's all hoses and tubes and whatnot. The two types of piping used in hydraulic system applications are black and stainless. Anybody know why they call it black pipe? Matthew?
Well, if you look on the outside of the pipe, it's clearly black, right?
It's black. Yeah. Black iron.
Ah,
But metals are typically shiny, aren't they?
The most common property of metal is that it's shiny.
Yeah. So if black pipe is iron, iron is obviously a metal, why is black pipe not shiny? I'm looking at you.
I think it's because of because of the properties of the black pipe, the metal of iron, way it's constructed, is why it's not shiny.
Okay. Brad, what were you gonna say?
That's cast iron.
No, it's definitely not cast. That's typically wrought iron. Anybody? Matthew?
Is it because it's not polished?
No. Can
Would the piping that we use on the trainers be considered black? The things that are sheet and rubber weave?
No, that's not piping, it's tubing.
Oh, okay.
Should've made that a quiz question. Somebody Google it, see what the official definition is. As far as gauge of pipes go, you have 40, 80, and 160. Schedule 40 pipe is the thinnest wall, 80 is the most
So,
heavy, and then the 160 is double extra heavy.
the dark color comes from the iron oxide formed on its surface during manufacturing. So it won't really use gas. No, different, galvanized.
You know, galvanized is zinc coated.
That's all it says.
Okay, but iron oxide is typically a red color.
So it's subjected to a blackening process.
Is it because of the color is painted?
Nope.
Is it because of the fact that it's been processed to make it black?
Yep. It's intentionally oxidized. So it's rust. Iron oxide. But iron oxide is typically red in color. It's like Mars is red. It is intentionally blackened. You know, what most people don't realize is in order to get red pigments, they start with black. And then you burn the shit out of it. Turns red. Try those kind of. Anyway, you can see on those three schedules, the outside diameter of each one of the pipes is exactly the same, 840 thousandths. Inside diameter is what's different, wall thickness. It gets heavier the higher the schedule number goes. That schedule 160 pipe can withstand a whole lot more pressure than schedule 40 can, but you can't shove near as much oil through it in the given, same amount of time. because the hole's so much smaller. Pipe threading. Pipes must be threaded to be interconnected and redirected. How do you redirect a pipe?
Put an angled connector on it.
Pretty much. Threading a pipe makes it possible to connect pipe to a pipe fitting. Or for a pipe and pipe fitting to connect, the OD of the pipe and the ID of the fitting must be the same size and have the same type thread. So if you try and screw an NPT fitting onto a BSPP threaded pipe, even if they're the same pitch, they'll go a little bit, but you will not ever get it sealed. Also, a lot of people don't realize, you thread a pipe back roughly an inch, but whenever you screw the pipe and the fitting together, all the sealing is done within the first couple of threads. The rest of them are there just for make the joint mechanically stronger. It doesn't help in how much it seals or not. Also, never, ever, ever, never use pipe dope in hydraulic system.
Is that like a putty?
Is it because, it can make a very explosive reaction?
No, it's because the little bits of the pipe dope sealant gets into the system and then gums up the insides of valves and things.
Pipe dope or pipe dough?
Dope.
Dope.
Dope?
D-O-P-E, dope.
It can gum up the
You should also never use pipe dope on a pneumatic system for the same reason.
I've also heard it's not too good for smoking. As we're talking about.
It's really hard to get it to smoke. Made of Teflon typically, which doesn't readily combust. Pipe insulation. When piping is installed, must be properly supported because vibrations in the hydraulic system. The purpose of these supports is to prevent strain or unnecessary pressure on the pipe joints, which can lead to leaks and premature system failure. When you do the install, there are charts that you can look up, Google it, no problem, whatever. Tells you, depending upon the pressure of the system, the diameter of the pipe, and all that good stuff. Sometimes it includes the usage and what it's being used for, type of fittings it's on it, all that good kind of stuff. How far apart your clamps and brackets and everything need to be. Tubing is an extruded tubular material used to convey fluids, more commonly used in hydraulic systems than in pneumatic systems. Talking about metallic tubing, yes. We're talking about plastic tubing, no. Tubing measurements. Tube measurements are stated by the size of the OD. Tubing schedule numbers are 5, 10, 15, 20. Schedule 10 and 20 being the most common. Tubing used for hydraulic systems must always be seamless. That's why it is an extruded tube as opposed to a welded tube. Tubing can be soldered, welded, or formed for compression. It can also be flared. Tube fittings, properly attached tubing to fluid power components. Tube fitting must be used. Two types are flared compression. flared tube, the end of the tube is literally flared out, looks like the end of a trumpet, only it's not quite that drastic. And in compression, there's what they call a ferrule, it's a sleeve that you slip over the pipe. And whenever you compress or tighten up the fitting, it actually compresses the ferrule around the tube so that it can't come off anymore ever again. For those of you that aren't observant enough, these are bins. Some of these slides crack me up. They get so juvenile. The hose is a flexible tube used for carrying fluids under pressure in both hydraulic and pneumatic systems and allows for movement of the components. Typically known as a hose in hydraulics and a tube in pneumatics. Now, hoses are used in the following ways: on or near energized electrical conductors or equipment under normal operating pressures, to attach pipes or tubes to equipment for protection from vibration and premature wear on joints. So, on or near energized electrical conductors or equipment under normal operating pressures, why would you need to have a hose there?
The hose is insulated against electricity,
Okay,
and tubing isn't.
what's that got to do with price of tea in China?
What's that have to do with what?
The price of tea in China.
It's a hazard if you're running conductive piping around electrical components.
It is possible to induce voltages, or if the insulation on the electrical conductor is damaged, you can energize the hydraulic system. And it doesn't matter which one of the shiny bits you touch, you're still going to get zapped. Hose selection. Stamped, an acronym. It's used to identify the following variables. S is the size, T is the temperature of the fluid, and the ambient air. A is the application where it's going to be used, M is the material, P is pressure, E is end on the couplings, and D is the delivery of the fluid product and documentation. Those are the exact quick disconnect devices that we use on the trainers out here in the lab.
I figured.
So this here and here are the springs that close the check valves. And you disconnect the tube. All of these oil fittings out here are have check valves on them, so that you don't pour all the oil that's in the hose out when you plug them together or unplug them. And box, well, I could move that up a little bit. Check valve, see that conical shape there? Goes into this seat, prevents the fluid from leaking out. Same thing on this side, but those stick out past the end of the fitting, so when you push the two fittings together, they open each other up to allow for the fluid to make it through. That is a restriction. So you have a half-inch fitting and you take up most of the internals with the check valves. It's no longer half-inch fitting. Okay, hose installation.
Nothing? No? Swing and a miss.
Okay, so I have a couple of examples of correct and incorrect hose installation. Top one there, it's got a bit of a sag in it. That just indicates that it's not tight like a guitar string. If you do something like this, you're just begging for failure in your system. Need to do a sharp bend like that, you'll want to use a fitting. Because if you do it this way, you got a lot of force here and a lot of force here, and your hose is almost guaranteed to fail prematurely.
Why is the short hose bad? Like what is the problem?
Well, the short hose isn't necessarily a problem. It's an excessively short hose. If you only got to go that far,
Okay.
you know, why don't you put a pipe in?
Also, it's that short and you're having to stretch it between two bits, you're kind of safe flexibility. Is that right?
If you want really short, something short like that, you would have to use piping, so it doesn't fail.
You want to avoid twists and sharp turns. So instead of doing this whole big loop. Unfortunately, at this point in the video, the AV system decided to fail. So the video locks up here and completely fails in just a couple of seconds later. So I will have to redo this video again at a later date.